we need to write the numbers below in digits. First, we have 7,203,027. So what we can do to write numbers in digits is read the number up until we see the word million, and we have 7 million, so we can write a 7 and then a comma. Then we continue reading the number up until we see the word thousand. We have 203,000, so we write the number 203 and then write another comma. Now we read the rest of our number after the word thousand. We have and 27. But remember, after the thousands, we need digits for hundreds, tens and ones. So we need to write 27 using 3 digits. So we write that as 027, so with a 0 in our hundreds. Now we have 8,200,300. We read the number and stop at the word million, so we have 8 million, so we write 8 and then a comma. Then we continue reading the number up to the word thousand, and we have 200,000, so we write 200 and then another comma. Then we read the rest of the number after the word thousand. We have 300, so we can write 300 after the second comma. Now 5,02,500. We write 5 and then a comma for 5 million. Now after the word million we have 2,000. But we need 3 digits to show our thousands place values. So we need to write 2 as 002 to show that the 5 is in our millions, and then we don't have any 100,000s or 10,000s, we just have 2,000s. Then after the word thousand we have 500, so we just write 500 after the second comma. Now 2,202,002. We have 2 million, so that's 2 and then a comma. Then we have 202,000, so that's 202 and then a comma. Then after the word thousand we have and 2. But we need 3 digits after the thousands, so we need to write the number 2 using 3 digits, so that's 002 to show that the 2 is in our ones and we don't have any hundreds or tens. We need to write the numbers below in words. So here we have 7-digit numbers. And when 7-digit numbers are written out, we either have 2 spaces or 2 commas like we have here. And these help us to write the number in words or to read the number, because the first comma or space always comes after the millions digit and before the 100,000s digit, and then the second comma or space in the number separates the thousands from the hundreds. So first, we can look at the digit written before the first comma. We have a 9, so we can write 9 million. Then we look at the 3 digits between the commas or spaces. We have 291, so we have 291,000, because remember, the thousands digit comes before the second comma. So then we can just look at our last 3 digits. We have 536. So our number is 9,291,536. Now let's look at this number here. Before the first comma we have a 4, so that's 4 million. Then, remember, we look at the 3 digits between the commas, because that tells us how many thousandths we have. We have 590, so that's 590,000. Then we look at our last 3 digits. But here we have zeros as our last 3 digits, zeros in our hundreds, tens and ones. So we don't need to write anything after the word thousand. Our number is 4,590,000. So now here, before the first comma, we have a 6, so that's 6 million. Then we look at the 3 digits between the commas, because these are our thousands digits. We have 070, but we can ignore the 0 at the start. We have 70,000. This 0 is only here to show that we don't have any hundred thousands, and the 6 is in our millions, stands for 6 million. Then we look at the last 3 digits, so the digits after the second comma. We have 040, so that's 40. Now rather than writing a comma after the word thousand, because we don't have any hundreds, when we write the number in words, we can just write and 40. So we still have a comma if the number's written in digits, but when we're writing numbers in words, if we don't have any hundreds, we can just write and then the number. So our number is 6,070,040. Now here, before the first comma, we have a 4, so that's 4 million. And then we look at the next 3 digits, so the digits between the commas, because this tells us how many thousands we have. But here we have zeros in all 3 of our thousands digits. So we don't write the word thousand. Instead, we just move on and look at the last 3 digits. We have 800, so our number is just 4,800,000. We don't write the word thousand because all the digits in our thousands place values, so in our hundred thousands, our 10,000s and our thousands are zeros. And if we have zeros, we don't write anything. We need to write the digit in each place value. So first, we have 7,451,194. Remember, with whole numbers, we count place values from the digit on the right. So we have our ones, tens, hundreds, then our thousands, 10,000s, 100,000s, and then our millions. So in this number here, the digit in the millions is a 7. And because it asks us just to write the digit, not to write the value of the digit, we just write 7. We don't write 7 million because we just need the digit, not the digit's value. So then we have 4 in our hundred thousands, 5 in our 10,000s, 1 in our thousands, 1 in our hundreds, 9 in our tens, and 4 in our ones. So now we have 5,709,846. First, we need to write the digit that's in our hundred thousands place. Remember, the hundred thousands digit is the 6th digit from the right, so we have a 7 in our hundred thousands. We could also find the hundred thousands digits more quickly if we remember that if there are 2 commas in a number, the first comma separates the millions from the hundred thousands. Then we have 4 in our tens. Our millions digit is a 5. Our thousands digit is a 9, because we can remember that if there are 2 commas or 2 spaces in a number, the digit before the second comma will be our thousands digit. Our ones digit with whole numbers is always the digit on the end, so that's a 6. With our 10,000s, we have a 0, because the 10,000s digit is the 5th digit from the right. And then our hundreds digit is an 8, because our hundreds digit is always the 3rd digit from the right, or the digit that comes after the comma separating the thousands and the hundreds. Now we have 2,043,198. First, we need to find our ones digit. With whole numbers, that's always the digit on the end, so we have an 8. But it's important to understand the ones digit is only the digit on the end if we have a whole number. Remember, if we have a decimal number, we need to count place values from the decimal point, not from the end. But with whole numbers, we can count from the end. So next, our hundreds digit is a 1. Our 100,000s digit is a 0, because the 100,000s digit is the 6th digit from the right, or the digit that comes after the first comma if we have 2 commas in a number, or 2 spaces. Then the thousands digit is a 3, because that's the 4th place value from the right, or the place value that comes before the second comma in a number, so the comma separating the thousands and the hundreds. We have 4 in our 10,000s. We have 2 in our millions, because if we have a number with 7 digits, the first digit tells us our millions, because that's the 7th place value from the right. And then we have a 9 in our tens. So we can show these numbers here using place value counters. So this 7 represents 7 million, this 4, 400,000s, this 5, 10,000s, this 1, 1,000, this 1, 100, this 9, 9/10s, and this 4, 4/1s. Then for 5,709,846, we have 5 in our millions, 7 in our 100,000s, 0 in our 10,000s, 9 in our thousands, 8 in our hundreds, 4 in our tens, and 6 in our ones. Then for 2,043,198, we have 2 in our millions, 0 in our 100,000s, 4 in our 10,000s, 3 in our thousands, 1 in our hundreds, 9 in our tens, and 8 in our ones. Now we need to write the value of each digit. So first we have the number 4,052,160. The 4 is in our millions place value, so stands for 4 million. That's 4 with 6 zeros on the end, because notice in our number, after the 4, we have 1, 2, 3, 4, 5, 6 zeros. Now, this 5 is in our 10,000s, so that stands for 50,000. That's 5 with 4 zeros on the end, because we can see that in our number, after the 5, we have 4 digits. The 2 is in our thousands place value, so the value of the 2 is 2,000. The 1 is in our hundreds place value, so that represents 100. The 6 is in our tens, so that stands for 60. Now we also have zeros in this number, but here we didn't need to write the value of the zeros, and that's because whatever place value they're in, the value of the 0 is always 0. So this 0 here is in our 100,000s place value, but because 0 times 100,000 is still 0, the value of the digit is still 0. Now we have 8,504,297. So first we need to find the value of the 2. That's in our hundreds place value, so stands for 200. Now the 4 is in our thousands, so that's 4,000. The 7 is in our ones, so that just stands for 7. The 8 is in our millions, so that's 8 million, 8 with 6 zeros on the end, because we have 6 digits or 6 place values after the 8 in our millions. The 9 is in our tens, so that's 90. And the 5 is in our 100,000s, so that's 500,000. 5 with 5 zeros on the end, because we have 5 digits after the 5 that's in our 100,000s. Now we have 2,638,041. The 6 is in our 100,000s, so that's 600,000. 6 with 5 zeros on the end because we have 5 digits after the 6. The 8 is in our thousands, so that's 8,000. The 2 is in our millions, so that's 2 million, 2 with 6 zeros on the end. The digit 1 is in our ones place value, so that just represents 1. The 4 is in our tens, and 4 tens make 40. And the 3 is in our 10,000s, so that's 30,000. 3 with 4 zeros on the end, because we can see that after the 3 we have 4 digits in our number. We need to partition the numbers below. So first we have 4,307,042. Now when we partition numbers, what we're doing is showing the value of each digit. So this 4 is in our millions place value, so represents 4 million. That's 4 with 6 zeros on the end, because we have 6 place values after our millions place value. Or, looking at our number, we have 6 digits after the 4, so we need to write 6 zeros after the 4 when we partition it. Now we have a 3 in our 100,000s, so that's 300,000. We have 5 digits after the 3, so when we partition the number, we need to write 5 zeros after the 3. Now the next digit is a 0, and we don't partition zeros. That's because whatever place value it's in, 0 always has the value of 0. So here, 0 is in our 10,000s place value, but 0 times 10,000 is still 0, so we don't need to partition 0. We can move on to the next digit. We have a 7 in our thousands, so that's 7,000. We have 3 digits after the 7, so when we partition, we write 3 zeros after the 7. In our hundreds, again, we have a 0, so we don't need to partition that because the value of 0 is always 0. But then our next digit is a 4, and that's in our tens, so stands for 40, and then we have a 2 as our ones digit. Now when we partition numbers, what we can do is add up our partitioned numbers, and when we do that, you'll notice that we get the number we started with, and that tells us that we've partitioned accurately and haven't made any mistakes. So now let's try 6,193,413. The 6 is in our millions, so that's 6 million. 6 with 6 zeros on the end, because we have 6 digits after the 6. The 1 is in our 100,000s, so that's 100,000. 1 followed by 5 zeros, because we have 5 digits or 5 place values after the 1 that's in our 100,000s. We have 9 in our 10,000s, so that's 90,000. 3 in our thousands, so that's 3,000. 4 in our hundreds, so 400. 1 in our tens, so that's 10. And 3 in our ones. And again, you can see that when we add up the number that we've partitioned, we get the number that we started with. So now we have 7,460,253. The 7 is in our millions, so that's 7 with 6 zeros on the end, because we have 6 digits after the 7. Then the 4 is in our 100,000s, so that's 400,000. The 6 stands for 60,000 because it's in our 10,000s place value. Now we have a 0 in our thousands, but we don't need to write zeros when we partitioned, because whatever place value it's in, the value of 0 is always just 0. We have zeros in numbers because they give other digits place values. So here we need this 0, so the 6 isn't in our thousand, but in our 10,000s, and the same for the 4 and the 7 as well. Now we have 2 in our hundreds, so that's 200. This 5 stands for 5 tens, and then we have a 3 in our ones. And again, you can see that when we add up the partitioned numbers, we get the number that we started with. We can also show partitioned numbers using place value counters. So our first number was 4,307,042. This 4 is in our millions, so we can show 4 million place value counters. The 3 is in our 100,000s, so we can show 300,000 place value counters. We have a 0 in our 10,000s, so we don't show any 10,000 place value counters. We have a 7 in our thousands, so that's 7,000. A 0 in our hundreds, so we don't show any 100 place value counters. This 4 stands for 4 tens, and this 2 for 2 ones. Then we had 6,193,413. So we have 6 in our millions, 1 in our 100,000s, 9 in our 10,000s, 3 in our thousands, 4 in our hundreds, 1 in our tens, and 3 in our ones. Our last number was 7,460,253. So that's 7 in our millions, 4 in our 100,000s, 6 in our 10,000s, 0 in our thousands, so we don't show any 1,000 place value counters. We have 2 in our hundreds, 5 in our tens, and 3 in our ones. We need to write the numbers below in order from smallest to largest. So first, we have 9,600,000, 696,000, 90,000, 6,990,000, and 9,660,000. Now when we're comparing numbers, we start by comparing the larger place values first. So here, our millions place value. But these two numbers don't have any digits in the millions. So when we look across to the 100,000s, we can see that this number has 6 in the 100,000s, but this number doesn't have any 100,000s. So we know that 90,000 is the smallest number, and then 696,000 is next smallest. Notice 90,000 only has 5 digits, and 696,000 only has 6 digits. All of our other numbers are 7-digit numbers, and when we're comparing whole numbers, numbers with fewer digits will always be smaller. So now, if we look at the numbers we have left, we have 2 numbers with 9 in the millions, but this number here only has 6 in the millions, so that means 6,990,000 must be next smallest. So now, both of these numbers have 9 in the millions, and when we go across to the 100,000s, both numbers also have the same number of 100,000s. They both have 6 as the 100,000s digit. So we need to move across again and look at our 10,000s. Here we have 6 in the 10,000s place value, but here we have a 0. So that means 9,600,000 must be next smallest, and so our largest number is 9,660,000. Now we have 77,666, 6,677,666, 7,777, 7,676,666, and 7,767,777. Again, we know that numbers with fewer digits will be smaller. So that means this number here, which only has 4 digits, is our smallest number, and then this number here, which only has 5 digits, is next smallest. So now we need to compare our 7-digit numbers. Here we have 6 in the millions, but both of our other numbers have 7 millions, so that means this number here is next smallest. Now for these remaining two numbers, because they both have the same number of millions, we look across to our hundred thousands place value column. Here we have 6 in the hundred thousands, but here we have a 7. So that means this number here is next smallest, and this number is our largest number. Now we need to round to the nearest 10, 100, 1,000, 10,000, 100,000 or million. So we have 7,451,194. To round to the nearest 10, we find the tens digit and then look to the right. We have a 4 in our ones, and when we're rounding, if we have 4 or less, we round down. And that means that the 9 in our tens stays the same. Digits to the left of the place value that we're rounding to always stay the same. So we have 7,451,190. Now to round to the nearest 100, we find our hundreds digit and look to the right. We have a 9, so we're rounding up. That means the 1 in our hundreds becomes a 2. Digits to the left stay the same, and digits to the right of our place value turn into zeros. So we get 7,451,200. Now to the nearest 1,000, we find the digit and look to the right. We have a 1 in our hundreds, so that means we round down. The 1 in our thousands stays the same, digits to the left stay the same, and digits to the right turn into zeros. So that's 7,451,000. To the nearest 10,000, we circle the digit that's in our 10,000s and look to our thousands. We have a 1, so we're rounding down. That means the 5 in our 10,000s stays the same, digits to the left always stay the same, so we have 7,450,000. To the nearest 100,000, we find our digit, and when we look to the right, we have a 5. That means we need to round up. So this 4 becomes a 5, the 7 in our millions stays the same, so that's 7,500,000. And now to the nearest million, we find the millions digit, and when we look to the right at our 100,000s digit, we have a 4, and if we have 4 or less, we round down. So the 7 stays a 7, and all digits to the right turn into zeros, so we have 7 million. Now we have 3,409,846. To round to the nearest 10, we find our tens digit and look at our ones digit. That's a 6, and if we have 5 or more, we know that we're rounding up. So we add 1 to the digit that we've circled, so this 4 becomes a 5, and then our ones digit turns into a 0, with digits to the left of what we've circled always staying the same. To the nearest 100, we find our hundreds digit and look at our tens. We have 4, so we're rounding down. That means the 8 in our hundreds stays the same, digits to the left always stay the same, and digits to the right turn into zeros. Now to the nearest 1,000, we find our thousands digit and look at our hundreds. We have 8, which means that we're rounding up. But we already have a 9 in our thousands, and we can only have 1 digit in each place value. So what we need to do here is look at our thousands and 10,000s together. We can add 1 to 09 to get 10. So digits to the left, so the 3 and the 4 stay the same, but then 1 more than 9 is 10, so we write that with a 1 in our 10,000s and a 0 in our thousands, because we can only have 1 digit in each place value. And then again, as always, digits to the right turn into zeros. Now to the nearest 10,000, we find the 10,000s place, look at our thousands and we can see that we're rounding up. So this 0 becomes a 1, digits to the left stay the same, and digits to the right of what we've circled turn into zeros. To the nearest 100,000, we find our 100,000s place, and we have a 0 in our 10,000s. That means we're rounding down, so the 4 stays the same, the digit to the left stays the same, and all other digits turn into zeros. Then, to the nearest million, we find our millions place, look to the right, and again we're rounding down. So the 3 in our millions stays the same, but all other digits turn into zeros. Now we have 2,042,242. To round to the nearest 10, we find our tens and look to the right. It's a 2, so we're rounding down, which means that the digit we've circled, so our tens digit, stays the same, and digits to the left always stay the same. We just need to change our ones digit into a 0. To round to the nearest 100, we find the place value, look to the right, and again we're rounding down. So the digit we've circled stays the same, digits to the left stay the same, and then our tens and ones digits turn into zeros. To the nearest 1,000, we find the place value, look to the right, we're rounding down, so the digit we've circled stays the same, digits to the left stay the same, digits to the right turn into zeros. To the nearest 10,000, we find the place value, and we're looking at our thousands digit. We have a 2, so we're rounding down. That means the digits we've circled and digits to the left stay the same, digits to the right turn into zeros. To the nearest 100,000, we find the place value. Again, we can see that we're rounding down, so the 0 stays a 0, and digits to the right turn into zeros. And finally, to the nearest million, we find the place value. Again, we're rounding down, so the 2 in our millions stays the same, and all other digits turn into zeros. So here we have some place value counters, and these can help us to understand how our number system works. So first we have 1 million counter. We can always exchange any counter for 10 counters from the place value to the right. So we could exchange our million counter for 10 100,000s counters, because 10 100,000s has the same value as 1 million. If we have 1 100,000s counter, we can exchange that for 10 10,000s counters, because 10 10,000s has the same value as 1 100,000. If we have 1 10,000 counter, we can exchange that for 10 thousands counters. If we have 1 thousands counter, we can exchange that for 10 hundreds. 100 can be exchanged for 10 tens. 110 can be exchanged for 10 ones. And 1 1 can be exchanged for 10 tenths. So now we're getting into decimal place value. Now I've written 1/10 on these counters, but I could also have written 0.1, because 0.1 is 1/10 in decimal form. If we have 1 1/10 counter, we can exchange that for 10 hundredths counters, because 10 hundredths has the same value as 1/10. And again, instead of writing 1 over 100, I could have written 0.01 on these counters. If we have 1 hundredth, we can exchange that for 10 thousandths counters. So we can always exchange a counter for 10 counters from the place value to the right. We can exchange the other way as well. So if we've got 10 100,000s counters, we can exchange those for 1 million counter. If we have 10 10,000s, we can exchange those for 100,000. 10,000s can be exchanged for 1 10,000. 10 hundreds can be exchanged for 1,000, 10 tens can be exchanged for 100, 10 ones can be exchanged for 110. If we have 10 tenths, we can exchange those counters because 10 tenths has the same value as 1 whole. 10 hundredths counters can be exchanged for 1 tenths counter because 10 hundredths have the same value as 1 tenth. And finally, 10 thousandths counters can be exchanged for 1 hundredth counter. If we have 10 of the same counter, we can always exchange those 10 for 1 counter from the place value to the left. Now we have some missing number problems for counting in powers of 10. So first we have 0.007. Counting in powers of 10 we can think of as being multiplying by 10. So with 0.007 we have 7 in our thousandths, but if we multiply by 10, this 7 will move to our hundredths, so we have 0.07. Multiplying by 10 again moves the 7 into the tenths, so that's 0.7. Then next, if we multiply 0.7 by 10, the 7 will move one place value to the left, so we'll move from our tenths to our ones, so that's 7. Next we have 70, then 700, 7,000, 70,000, 700,000, and then 7 million. So if we show the numbers we've written with the place values lined up, you can see that the 7 moves from our thousandths to our hundredths to our tenths, then to our ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions place. You can also see that with decimals we need to write zeros before the 7 if it's in our thousandths or our hundredths place, and with whole numbers we need to write zeros after the 7 to make the place value of the 7 clear. So now we have something and we've multiplied by 10 to get 40.29. So our number must have been 4.029. Then we had 40.29, 402.9, 4,029, 40,290, 402,900, then 4,029,000. And we can see that if we write the numbers out with the place values lined up, that digits are moving one square to the left each time, and that's because we're counting in powers of 10 or multiplying by 10 each time, and then we have zeros as placeholders where we need them. So our thousandths, hundredths, tenths, ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions are lined up, so we can see that we're moving one square to the left each time. So now, this time, we're counting in powers of 10, but we're counting backwards, so we're dividing by 10 each time. So first, we have 4,600,000. So if we divide that by 10, we get 460,000, because dividing a number that ends in a 0 by 10, if it's a whole number, we can just remove one end 0. We can do the same here to get 46,000. Then we get 4,600, 460, 46, but then if we divide 46 by 10, we get 4.6, then 0.46, then 0.046. And we can see the pattern if we write the numbers out with the place values lined up, so with the decimal points lined up, and then with our whole numbers lined up as well. Again, we have place value columns for our millions, 100,000s, 10,000s, thousands, hundreds, tens, ones, tenths, hundredths, and thousandths.